This is the next video in the chapter on chemical bonding and molecular geometry. We have just learned all the tools we need to make some basic Lewis structures with multiple atoms in them. So we're going to start making those using a handy dandy flowcharts that I have posted for you to use as well. So this flowchart helps with the process for determining a Lewis structure and tells you which step to do. This is something you want to plan to eventually outgrow because you will not be able to use this in a testing environment, but you can use it while you're learning right now. So when we're drawing a Lewis structure from scratch, the first thing we do is we count the total number of electrons in a structure. And that comes from the valence electrons, depending on their group. The second thing we do is we draw a skeletal structure. We put 2 electrons in each of those bonds. We identify the terminal atoms. We complete the octet of the terminal atoms. We subtract the number of electrons used to this point from the total number of valence electrons to find if any remain. And then we check the octets. So there are several pieces of terminology here that we don't know. So let's go over those first. The first one is a skeletal structure. Let's talk about what a skeletal structure is so we can use that. So a skeletal structure is basically a structure with the bonding pairs only. Something we do at the beginning while trying to figure out how the atoms are arranged in a molecule. And so we have rules for how to determine where an electron is. For example, if we had this molecule, we could draw the carbons and the oxygens in the center, and we would draw the hydrogens along the outside. And we care a lot about where a particular atom lives, so we have names for these positions. The positions on the end, these are called terminal atoms. And a terminal atom is something that only is bonding to one other atom. And then over here in the center, these are called central atoms. And central atoms are bonded to 2 or more other atoms. So there are some elements that prefer to be a terminal atom, and there are some elements that prefer to be a central atom. We have a couple of general rules. So hydrogen is always a terminal atom. And this is for the same reason that it's an exception for the octet rule, is it can only hold 2 electrons. So it can only bond with one other thing in the molecules that we draw. So it always has to be on the end where it's only taking one bond. Carbon is always going to be a central atom. This is because carbon has 4 valence electrons and it needs 4 more valence electrons. And as far as we know, in these nice small-sized molecules, a quadruple bond is very unlikely. So that means that carbon is going to have to be in the center with at least 2 bonds to be able to get its 4 missing valence electrons. And for all of the other elements, if we have to make the choice about what goes in the center, we will choose the least electronegative atom to be the central atom. Remember that electronegativity is greatest on the right and at the top of the table. So we're going to pick something that's at the bottom left of the table to be our central atom, like carbon or like oxygen. So let's use the flowchart to go through an example because I think that's the easiest way to understand how this works. So let's start with NH4. So flowchart, first step, count the total number of electrons in the structure. So we can use the periodic table to help us. So nitrogen is here in group 15. So we have 1 nitrogen, and group 15 elements have 5 valence electrons. We have a hydrogen. Hydrogen only has 1 valence electron. So 4 hydrogens, 1 valence electron. And then we also have to count electrons from the charge. So this positive charge indicates there's 1 missing electron. So we'll subtract 1. So 5 plus 4 minus 1 is 8 valence electrons total. Okay, our next step is to draw the skeletal structure. So that means we have to make a decision about which element goes in the center and which element goes on the terminal side. We know there's a rule about hydrogen. Hydrogen is always a terminal atom. So that means that nitrogen is going to be in the center. So we put the nitrogen in the center and we put the 4 hydrogens around it. So that's our terminal structure. The next step in the flowchart says to place 2 electrons in each bond in the skeletal structure. So we'll have 2, 4, 6, 8 electrons in those 4 bonds. So I like to subtract the number of electrons I've used from my total count to help me keep track of which ones I've used already. So there's 8 electrons in the bonds, and there were 8 valence electrons available. And that means I now have 0 valence electrons left. So I can already tell that I'm almost finished because I've run out of electrons. But let's continue through the rest of the steps just to check. So the next step is to identify the terminal atoms. Those are the hydrogens. We'll complete the octets of the terminal atoms first, these guys on the outside. They are already completed because hydrogen only wants to have 2. Subtract the number of electrons used at this point from the total number of valence electrons. Do any electrons remain? We already saw that we subtracted and we were at 0. So their answer is no. So we move to the right. Do all atoms have complete octets? And if yes, we're finished. And if no, we have more things to do. So let's go through and check the octet. So we know hydrogen technically only needs a duet, and that both the electrons in this bond are shared by hydrogen. So it has 2. This hydrogen is bonded, so it has 2. This hydrogen is bonded, so it has 2. This hydrogen is bonded, so it has 2. And then we'll check nitrogen. Nitrogen needs to have 8 electrons in its octet, and it's got 2, 4, 6, 8 bonding electrons. So it has a complete octet. So all of these atoms have complete octets. Those are the only structures we're allowed to make right now. And the final step is to make sure that that positive charge is accounted for in our picture. So we'll put our picture in brackets, and we'll put that positive charge on the outside to indicate this entire molecule is positively charged. So far, so good. Let's move on to a trickier one. Let's do OF2. So the first thing we need to do is to count the number of valence electrons according to our flow chart. So we know oxygen, there's 1 of those, and it lives in group 16, so it has 6 valence electrons. There are 2 fluorines, and those live in group 17, so they each have 7 valence electrons. So 6 plus 14 is 20 valence electrons total. Oops. All right, our next step is to draw a skeletal structure, decide which one goes in the center. So we don't have a hydrogen or a carbon, so we need to find the least electronegative atom. So let's have a look at our periodic table. Here's oxygen and here's fluorine. So fluorine is the most electronegative atom that exists because it is at the top rightmost position, excepting the noble gases, which are not electronegative. So oxygen is going to be the least electronegative of the 2. So we'll put oxygen in the center and fluorine in the terminal positions. Okay, then we put 2 electrons in each bond. We'll put 2 there and 2 there. So we'll subtract 4 electrons in bonding pairs. And then we need to find the terminal atoms, which we did, and complete the octets of the terminal atoms. So each of these fluorines already has 2 shared electrons, and it needs to have 8 total. So we need to add 6 more to each of those fluorines. So now each of the fluorines has 2, 4, 6, 8. 2, 4, 6, 8. The next step says subtract the number of electrons so far and see if we've used them all. So we have just added 2, 4, 6, 8, 10, 12 electrons in lone pairs. 20 minus 4 minus 12, we have 4 valence electrons left. So this time, are any electrons left? The answer is yes. So now we place the remaining electrons on the central atom or atoms. So we need to place those 4 remaining electrons on our oxygen to help finish the oxygen's octet. So we'll give it 2 more lines for those last 4 electrons. Minus 4 electrons in lone pairs again. And now we've used them all. And we've also apparently used all of my ink. There we go. Okay, so all the valence electrons are used. On the central atom, check. Do all atoms have a complete octet? So we've already checked the fluorines, so now we check the oxygen. It has 2 4 valence electrons in lone pairs, 6, 8, another 4 electrons in bonding pairs. So yes, we have complete octets here. So this is a legal structure. We've used all of our electrons, all of the atoms have a complete octet, and we are good to go. Let's go ahead and do one more. We'll do C2N2. So carbon, there are 2 carbons, and carbon is in group 14. So there are 4 valence electrons. We're going to switch pens again. Then we'll do nitrogen. Nitrogen is in group 15, so it has 5 valence electrons. So 8 valence electrons total. Okay, our next step is the skeletal structure. So we know carbon is always central, but there are 2 carbons. So the question is whether we should make 1 central carbon or 2 central carbons, because as the molecule gets bigger, like the one up here, we can have multiple central atoms. So let's say we went with 1 central atom. So we'll put the carbon in the center, and we'll put the other atoms around the outside, like so. And I went ahead and put in the electrons in the bonding and identify the terminal atoms. Terminal atoms are nitrogen, nitrogen, and carbon. But this breaks the rule that we left for ourselves. We said carbon must be a central atom. And if carbon is not in the center of this set of 4, then it is on the edge, and we don't like that. We want carbon to always be central. So let's try again. Let's see if we can find a way to make both of the carbons central. So to keep them central, we need to put something on the end of the chain. So we'll put 1 nitrogen on the end of each chain. So we technically went back. We went back a step and we redrew the skeletal structure. We put 2 electrons in each of the bonds. Our terminal atoms are now nitrogen and nitrogen, and that looks better. So now we're going to complete the octets of the terminal atoms. So let's see. Nitrogen has 2 electrons associated with it, so it needs 6 more. And this nitrogen needs 6 more. So now we're going to take the difference to see how many electrons we've used. We have used 2, 4, 6, 8, 10, 12, 14, 16, 18. Gotta be careful with our counting at this point, because if you lose count, you're going to have a weird looking structure. So we have now used all the available electrons. So yes, we've used them. I guess no electrons remain. So now we check to make sure all the octets are completed. So we'll check the nitrogen on the end first. It's got 1, 2, 3, 4, 5, 6, 7, 8. Complete octet. 2, 4, 6, 8 for the left nitrogen as well. And for the carbon on the left side, it's got 2, 4. and that is not 8. And the other carbon has 2, 4 as well. So we haven't completed the octet for the 2 carbons. So that means we need to try out the last loop of the flowchart, which is if all the octets are not completed, we're going to form multiple bonds as needed to complete the octet. So up until this point, we have shown that each bond involved in equal sharing. The electron, one electron comes from the left atom and one electron comes from the right atom. But in some cases, we can have unequal sharing. Because carbon really needs more electrons to complete its octet, the nitrogen can share 2 electrons of its own into that bond. So let's try having each nitrogen share in another pair of electrons to give to that carbon. So I'm going to draw an arrow to show that I'm going to move from this structure to a different structure. We'll go back to skeletal structure, nitrogen, carbon, carbon, nitrogen. And now one of these lone pairs is moved in to become a second bond for each of them. And now there are only 2 lone pairs left on the outside. So let's double check our count to make sure we didn't lose anything. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, sometimes electrons get lost. We want to be careful. Now we'll check the formal charges again. So the nitrogens have 2, 4 in the lone pairs, 6, 8 in the bonding pairs, and these are the same on the left side. For the carbons in the center, we've now got 2, 4, 6 in bonding electrons. So we've got more, but we still don't have enough. So we're going to have to ask the nitrogens to share even another pair into each of those bonds. So we'll draw another single-headed arrow, and we'll try our structure again. Nitrogen, carbon, carbon, nitrogen. Now we have a triple bond in between each nitrogen and carbon. We still have a single bond between the 2 carbons. That hasn't changed. And the lone pairs on the end, there's only 1 lone pair for each nitrogen now. Let's make sure we have the same total number of electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18. Good, we haven't lost any. And let's check our octets again. So nitrogen on the end now has 2 electrons in lone pairs, 4, 6, 8 electrons in bonding pairs, and 2, 4, 6, 8 for this one as well. Carbon has 2, 4, 6, 8 bonding electrons, and so does the other. So we finally have all complete octets. We are finally done. And because I've drawn multiple structures now, it might be sort of unclear which structure was my final choice. So I'm going to put a box around this one to make sure it's really clear that these are not acceptable Lewis structures and this one is. So you can see that this process is a little bit of an iteration. You make one skeletal structure and you fill it with electrons and you check and see whether the octets are filled. And you may have to go in and make changes, push electrons in between different positions and recheck all of the electron counts and recheck all of the formal charges. We always want to make sure that the formal charges, that octets are complete for each of these different atoms. So in the next video, we will move on to more advanced Lewis structures than these.